Hello again, everyone. This is Michael Hicks, your professor in Business Administration 602. Last week, we talked about supply and demand. I introduced you to the basic model graphically of supply and demand. And what I introduced to you was a model that had representative consumer who demanded goods, and as the price of the good dropped, they purchased more of the good. That's the law of demand. And we had a representative producer who, as the price for a product rose, produced more of the good. That is the law of supply. What I'm going to do today, and in this block in two different lectures, is show you this algebraically, because the graphic's important, but it's good to see the algebraic expression, because this is going to reappear in later economics courses, managerial economics. And it sort of gives you a sense of some power and limitations to this process. So let's just go through what we described. So that this highlighted area here is that law of demand. It said the price demanded for a product is going to be equal to an intercept A minus B times Q, or quantity. And B is the slope and A is the intercept. Right, and I just warn you right now, economists are, throw out Greek letters, and I'm not going to do that just for this, because I think your first introduction is better to stick with plain old letters here. But price and quantity, A is an intercept, B is a slope. That's the law of demand. The law of supply says the opposite. It says the price of supplied is going to be equal to an intercept, and that's an intercept C. It's different than A, plus Z, which is a slope, times Q. So this is a positive slope line, right? This is the law of supply. So what we're interested in the graphic to find what we call equilibrium, or a resting point, is to find the equal point of these two. So I've shown you, what that is. And I've rearranged some terms here, right? I made a quick mistake here, right? But let me rewrite this real quick just so that we can preserve what we had up there. All right, so what we did was set the two prices equal. So that's that intersection of supply and demand, where price demand is equal to price supply. And then without rearranging terms, what we end up with is these two things would be equal. We'll just move them to different sides of the equation. And what we end up with is price on one side, and then this other stuff over here. And I'm not worried too much about signs, and I'll explain why in a minute. But what we end up is with an equation that is hard to interpret, because you have two intercepts here instead of one, and you have two different slopes affecting quantity. So this is the fundamental problem with economics in supply and demand, is that what we actually observe in an equation in equilibrium is the equilibrium price and quantity. And in order to do a really good estimate to decide which is which, we would have to do more sophisticated modeling. And we probably won't even get into that in managerial economics, but we would have to independently calculate supply and demand. And I'll show you that in the next block. But normally, those two equations aren't enough to really provide something interesting. We know there's a law of supply. We know there's a law of demand. And we are less concerned with the slope of the demand curve as business people as we are to how responsive supply and demand would be to a change in price. So we might not be interested in the pure economics of this. We may just be interested how, in a simple question, how does quantity vary with price? Well, the quantity the equilibrium quantity here is determined both on supply and demand, right? So this equation here doesn't really give us the information we want, right? Um, so let's skip ahead. And on top of that, we might want to know something else. So let's say we wanted to know, as business people, how responsive is price to changes in quantity, and how responsive is price to income, average income in the region. Do price home values go up when people are richer? Do they go down? And so we would want to know that. And so um, let's say we want to just estimate this function where price is a function of quantity and incomes, right? So we would rewrite this last equation here, right? This largely gobbledygook, uninterpretable equation is something new. So now we have price is equal to an intercept. So that A is equal to that little A plus C up there, right? Then we have a big B, right? We're just rewriting a B. That's the responsiveness of quantity to price in this equation. And then G, which is the responsiveness of income, of price to income, times income. So these are the slope in the income space, and that's the slope in the quantity space. Now, here's the problem. A is a common intercept. It loses most of its interpretation. So thinking about that A there is not, it doesn't really enter into our calculation anymore. It's a placeholder. B is the slope of the demand curve, the observed curve, demand curve, and the supply adjustments. All right, so it's a combination of the slope of supply and demand. And G is the slope of the price to the income curve. This is called a reduced form equation. So what we did, instead of having two equations, one law of demand and one law of supply, we wrote it all out in equilibrium into an equation that looks like that. Now, what we often do in economics is write this something like this. So we'll have P is equal to, we just have A, because we're going to test this on cross-sectional data, plus B, and we'll call this 1, and we'll make it a sub 1 here. This is often how this is written, times Q. No. Right, plus G sub 1 plus I, or times I, excuse me. I'm going to rewrite this. Right, and then we could add other things. We could add other measures. We could add a B sub 2, right, times tastes or preferences. We could have a B sub 3 times price of a related good. I haven't told you what good this is, so we're moving on. Right, so we could have now a reduced form equation that gives us interesting information. So the B1 gives us the responsiveness of price to a change in quantity. G1, and that's a slope of the demand curve. G1 gives us the responsiveness of price to a change in income. So that would be a slope of the income and price line. Recall that when I was explaining supply and demand, I said there are infinite number of different options out there. B2 is tastes, as the slope in tastes and preferences. I got to be honest, I don't know how to measure taste and preferences, so we might not have good information on that, and I'll get to that in a minute. And then we have B3, which is the price of a related good, complements or supplements. And we could have 10 different related goods. So we could have B4, B5, B6, all the way through B13 of different prices of related goods. And that's a very valuable in a business context. You might, let's say you're selling furniture in Indianapolis, and you want to know about income changes, you want to know about number of households, you want to look at interest rates because that influences whether people buy homes. And so you could build an equation that is a function of all of these things. And so you think, oh, okay, gosh, there's a couple of problems here. Where do I get the data? And how do I come up with these values? How do I come up with these slopes? Well, two things. One is that much of the data that you may wish to use could be publicly available, and you could pick it up, download it. I'm actually going to provide some of it to you. In business, if you're trying to forecast the price, the likely changes to price of something, you'd want to know what the other prices are out there. You'd have to have some mechanism for gathering price, and you'd like to have lots of observations. This is a course that talks about statistics, so we don't want to walk too far away from all of that. And so the problem is, a couple of problems here is something we may not have any data on. So we might not have any data on tastes, right? And so what we do in these models is we add an error term, right? Or a residual. And that explains the degree, that is a value of high or low of each observation that we try to minimize to draw the best fitting line. And so what I've introduced to you now, this is the first example where we have matched an economic idea to a statistical model. And so what I'm going to do now is stop and show you actual data and show you actually how to test that actual data so that you can get some sense of what we're trying to do in this course. And so that ends this lecture.